everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on the construction of transformer and working principle of transformer, and next types of transformer. So first here, overview of transformer. The real picture of transformer, it looks like this. Now here it is a electromagnetic energy conversion device. It is not electromechanical conversion device. Electromechanical conversion devices are generators and motors, but it is a this point is most important. Electromagnetic energy conversion device. It transfers electrical energy from one circuit to the another circuit without any electrical contact through the magnetic material. It transfers electrical energy from one circuit to the another circuit without changing the supply frequency. Now here see the definition. The transformer is a static device. There are no rotatory parts and it transfers electrical energy from one circuit to the another circuit with same frequency. Now next here it consists of two circuits, circuit 1, this one, and circuit 2, and this is a magnetic core, and with two different levels of voltages without changing frequency, with same frequency, supply frequency and load frequency is same, and there is no electrical contact between two coils, and it transfers electrical energy from one circuit to the another circuit. Now this transformer is used in the distribution systems and electrical power systems. In the transmission systems we will use. Now here the symbol of transformer is this one. So this is a primary winding, this one is a secondary winding. This two parallel line indicates the magnetic core. What are the parts in the single phase transformer? Prime winding and magnetic core. There are two parts that I will explain in the next slide. So the symbol of transformer and the construction of transformer, it looks like this. Now here it transfers electrical energy from one circuit to the another circuit without changing frequency and without any electrical contacts. It transfers electrical energy from one circuit to the another circuit. Now here there is no, it works on the principle of mutual inductance only. Mutual inductance concepts means two coils are coupled mutually. So there is no electrical connection. So if current change in one coil and induced EMF will be developed in the other coil. If current changing in the other coil and induced EMF will be developed in the other coil. So that principle we will use in the single phase transformer construction. Now next, what are the parts here? So first part is the core, magnetic core. Here core is a magnetic, this is the magnetic core, this rectangular, it may be a rectangular shape or square shape. Now see the core of the transformer, single phase transformer, either square or rectangular. So this shape should be either square or rectangular, and it is further divided into two parts. So first part is the yoke and second part is the limb. So limb and yoke, these two are most important. And next, the vertical part of the transformer core is limb. So this is limb 1 and this is the limb 2. This is limb 1 and this is the limb 2. And this horizontal part of the core is known as yoke. This one, yoke 1 and yoke 2. Now here the vertical portion which coils are bound, are known as limb, and here the horizontal part of the horizontal portion of the magnetic core is known as the yoke. Now here next part, the material used for this core is here laminated, and the material is silicon steel, here silicon material, to reduce the hysteresis losses. And next, to reduce this is laminated construction. So why we are using laminated construction here? To reduce the eddy current losses. The laminated type of core we will use. Next, silicon material. Silicon steel material is used to reduce the hysteresis losses. Now here we have two types. Core, if there is a core in the machine, in any machine, if there is a core, means there are two types. Core losses are divided into two types: eddy current losses and hysteresis losses. To reduce the eddy current losses, the core must be laminated to reduce the eddy current losses, and to reduce the hysteresis losses, the core must be made up of with silicon steel material, high grade silicon steel material. The thickness, that lamination thickness is 0.3 to 0.5 millimeters thickness. Now here next part is, it is a magnetic material, not electrical material. Now here this one, windings. So there are two types of windings. First one is a primary winding and second one is a secondary winding. Now main purpose of winding. So there are two windings. First one is the primary winding and second one is the secondary winding. So these windings are wound on the limbs only. Wound on the two limbs, limb 1 and limb 2. Limbs of the core. Vertical portion of the magnetic core is known as limb. So these windings, primary windings and secondary windings, are wound on the limbs of the magnetic core. Both the limbs of the magnetic core, which are insulated from each other and from the limbs only. There may be insulation. Now here the windings are made up of with copper wire. So for any winding we will use copper. So if the copper wire resistance is very small, so that high amount of current flows. Now the definition of primary winding. So the winding which is connected to the supply is known as this is the magnetic core, and these windings are wound on the limbs of the core. The winding which is connected to the supply, transformer works on the AC supply only. The winding which is connected to the AC supply is known as the primary winding. The primary winding turns are N1. This is the primary winding if it is connected to the AC supply. And the winding which is connected to the load, this is the load. That is secondary winding. Secondary winding turns are N2. So now core and winding. Now here, what are the types? There are two types of, depending upon the core type. So if it is a core is divided into two parts. So first core type and shell type. So first I will explain core type transformer, then I will explain shell type transformer. Core type transformer, it looks like this. So magnetic core, and these are the windings, primary winding and secondary windings. So this is the primary winding and this one is the secondary winding. Now here, the magnetic core of the transformer is made up of with laminated. Already we discussed in the core construction, that is either rectangular or square, that is laminated. So that construction, that laminated cutting is L shape, or this is the L shape or U shape, UI shape, L and L shape. This is the L and L shape, L and L shape, or U and U shape. If you connect both, so L and L, that is a square, and if U and I connect, that is also square or rectangular. So it is a rectangular shape or square shape. So that strips are L, 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 L like this. So now it is a rectangular or square, and U and I, it is a rectangular shape. Now here The real picture of core type transformer. So this already I shown in the previous slide. Next, insulation layer is provided between lower winding and between primary and secondary winding. Between primary and secondary winding, there may be insulation, and lower winding and a higher winding, there may be insulation. Here, this lower winding is near to the core, and this higher winding, higher voltage winding is around this lower voltage winding. And for reducing the insulation, lower winding is always near to the core. So this lower winding is always near to the core, and higher voltage winding is around this lower voltage winding. And the windings are here cylindrical and laminated is inserted later on. Next, shell type transformer, it looks like this. So here we have three. This is the core. Another extra limb is here. So now here, this is the core, and primary winding and secondary winding wound on the middle limb. So here three limbs here, and this is a magnetic flux. So now here, the core cut is in the form of E and I. So if you see the diagram, now this is a E and I, and E also. So now this is a E shape, and this is the I. So it looks like this, three limbs, and R, E, and another E. So it is also shell type. Shell type transformer consists of three limbs and two yokes. Now, the real picture, it looks like this. So E and E, so it is a laminated construction. Laminated construction main purpose is to reduce the eddy current losses. Now here the shell type transformer consists of three limbs, 1, 2 and 3. Three legs. Limb we can call it as a legs. The central limb carries the flux. This one, if you see this diagram, so see this diagram. So this is the central limb, and this one is these two are outer limbs. So central limb carries the whole flux, that is 5, and the side limbs carries the half of the flux, 5/2. Hence, the width of the central limb is about double of that of outer limbs. So this is a 5/2 and this is a 5/2. So now here total flux is 5. Now primary winding and secondary winding are wound on the middle limb only, central limb only. Here it is a primary winding. This is the primary winding which is connected to the supply. It looks like this, and secondary winding also is connected to the load. This is the primary winding turns N1 and secondary winding turns N2. V1 supply and V2 is the load voltage. And here primary winding, and this is the primary winding, and this is the secondary winding. So wound on the middle limb only. Now here the difference between core type transformer and shell type transformer. I will explain one by one each point. First, the definition: core type transformer in which magnetic core consists of two vertical sections. So here two vertical sections, and that vertical sections are called limbs, and two horizontal sections called that are yokes. These are the limbs and these are the yokes. The windings are wound on both the limbs. The windings are wound on both the limbs. This red color indicates that are winding, and this green color indicates low voltage winding, and this red color indicates high voltage winding. So this low voltage winding are wound on the limb, and this high voltage winding wound on the low voltage winding, and these windings are placed on the limb is called core type of transformer. This is the core type of transformer. Now what about the shell type transformer? Shell type transformer in which the magnetic circuit consists of one central limb, total 3 limbs here. So one is central limb and another two are outer limbs, two outer limbs and one central limb. And the both primary winding and secondary winding are wound on the this is a primary winding and this is the red color is the primary winding and green color is the secondary winding. So now here both windings are wound on the central limb only. Such type of construction is known as the shell type transformer. Next, here in the shell type transformer, windings are surround on the core. Windings are wound on the core only, but in case of shell type transformer, core wounds the winding. So this is the reverse case. Here winding is wound on the core, but here core wounds the winding. Next, the shape, the laminations. So both are laminated constructions. Here the shapes are U and I shape. Here the shapes are here E and I shape, and U or T shape, U shape or T shape also we can use this one. Next, the cross-sectional area. The cross-section of core indicates here the cross-section of core of the core type transformer may be this is the square and this one is the rectangular shape. And next, core type of it consists of 2 limbs and it consists of 3 limbs. And next, core type transformer consists of single magnetic circuit, but here it is having it consists of 2 single magnetic path, and but here we have 2 magnetic paths. Here this is 5 by 2 and this is 5 by 2 and this is the 5. Here we have 2 magnetic paths. Here only we have single magnetic path. Next, here we will use here concentric winding, that is cylindrical winding, but here we are using sandwich winding, that is also known as a disc winding. So what are the applications of core type transformer? Core type transformer applications are for high voltage and high power applications. We will use core type transformer for transmission for purpose, for distribution purpose, and for low voltage and low power applications, low power applications, we will use shell type transformer. Now here the working principle of transformer, single phase transformer working principle, how it will works. So how electrical energy transfers from one circuit to the another circuit without any electrical contact, without any rotating part, how it will, it is a static device. So now here, so the I will represent the terms first. Here transformer, this is the transformer core. Transformer core having 2 windings. First one is a primary winding and this is a secondary winding. Primary winding turns are N1 and secondary winding turns are N2. The winding which is connected to the supply is known as the primary winding, and the winding which is connected to the load is known as the secondary winding. So primary winding voltage is V1 and load voltage is V2, and E1 is the induced EMF and E2 is the induced EMF in the secondary winding. E1 is the induced EMF is the primary winding. These terms I will explain in the working concept. So first, how it will works. So first, when you give the AC supply, transformer works on the AC supply only. It will not works on the DC supply. It will not works on the DC supply. It will works on the AC supply. So how it will works? So when you give the AC supply to the transformer primary winding, so then current flows. There is a closed path and current flows in this primary winding. So that current is I1. V1 supply, V1 AC supply is given to the transformer primary winding. I1 current flows in the primary winding because of this closed path, and this I1 flux sets up the flux 5 according to the right hand thumb rule. So now here 5 flux setups in the transformer primary winding, and this 5 flux links with the magnetic core. What is the main purpose of magnetic core? It provides the definite path for the linking flux, this flux. So this flux here 5. So magnetic core link this primary winding, and this flux links with the magnetic core, this primary winding flux. So now here this flux is flows like this in the rectangular shape, and it links with the secondary winding 5 flux. And now we know that mutual inductance concept. So if current change in one coil and induced EMF will be developed in the other coil, how it will generate mutual inductance concept without any electrical contact, how it will transfer. There is a change, there is a d phi by dt. d phi by dt E is directly proportional to the d phi by dt according to the Faraday's law of electromagnetic induction. Now here there is a induced EMF will be developed in the secondary winding. So that is mutually induced EMF E2 and primary induced EMF E1. Self-induced EMF will be developed in the primary winding. Now if there is no load, no current flows, and if you connect the load and current flows in the secondary winding, that current is I2. I am repeating the working principle again. If you give the AC V1 supply, AC supply is given to the transformer primary winding, that current flows in the primary winding because of open circuit, because of this closed circuit, and this current setups the flux, that is 5 flux, and this 5 flux links with the secondary winding, this magnetic core, and this magnetic core provides the definite path for this flux 5, and this 5 flux links with the secondary winding. And according to the Faraday's law of electromagnetic induction, E is directly proportional to the d phi by dt, and induced EMF will be developed in the secondary winding. That induced EMF is mutually induced EMF, and next induced EMF will be developed in the primary winding. That induced EMF will be the self-induced EMF. Now here there is no load and there is no current. If you connect the load, that current flows in the secondary winding, that current is I2 and load voltage is the V2. In this way, the electrical energy transfers from one circuit to the another circuit without changing in the frequency. It works on the principle of mutual inductance between two magnetically circuits, and primary is connected to the this voltage should be RMS AC supply. That is V1, and current flows to this winding, and it sets the alternating flux, that is 5. This flux links not only links with the primary winding but also links with the secondary winding, and E1 and E2 will be developed in the secondary winding. So now according to the E is directly proportional to the d phi by dt. This E1 equals to minus N1 d phi by dt, and E2 equals to minus N2 d phi by dt. So why here minus here according to the Lenz law? And E1 by E2, if this is equation number 1 and equation number 2. 1, if you do 2 by 1, you will get E1 by E2 and N1 by N2. Both are equal, that is K, that is the transformation ratio. Now here, this one, here E1 and E2, and it carries the current. So that currents are here I1 and I2. Now E1 by E2 equals to N2 by N1, that equals to I1 by I2. This is the most important. In this way, electrical energy transfers from one circuit to the another circuit. This is the energy, power transfers from electrical energy from one circuit to the another circuit. It will transfers without any electrical contact. It transfers electrical energy from one circuit to the another circuit without changing in the frequency. Supply is frequency. Supply is constant, frequency is constant, flux is constant, and there are no rotatory parts, static device, and without any no electrical contact through the magnetic field, it will transfers. Thank you. Thank you very much to you all.
Like, share, and subscribe. Hit the bell icon for more updates.